Hello everybody, this is Rob Swatsky from the York campus of Hack, and welcome back to my Biology 121 Anatomy and Physiology 1 course. This is podcast 2.2a, Chemical Bonds, Ionic Bonds. Chemical bonds are the relationships between atoms that hold together molecules or compounds. Out of the three subatomic particles that make up atoms, the protons, neutrons, and electrons, it is the electrons that play the major role in the formation of chemical bonds. In particular, it is the number of electrons in the outermost or valence shell of an atom that indicates how likely an atom will form a chemical bond with another atom. Matter always wants to be in its most stable state. An atom containing 8 electrons in its valence shell, or 8 valence electrons, is considered to be chemically stable and is unlikely to form chemical bonds with other atoms. Unstable atoms have less than 8 valence electrons and will be more likely to react with other atoms in order to form chemical bonds with them, and as a result, more stable products. As a result of the bond, each atom will end up having 8 valence electrons. The general rule that describes the stability of an atom having 8 valence electrons is called the Octet Rule. An octet is a group of 8 electrons. Remember that for most atoms, the maximum number of electrons that makes their electron shells full is 8 electrons. You can think of the 8-ball used in playing pool to help you remember the Octet Rule. The exception to the octet rule is in the case of hydrogen and helium. Hydrogen has only 1 valence electron, and helium has 2 valence electrons. Both of these atoms have just 1 electron shell, the first electron shell closest to the nucleus, which can hold a maximum of only 2 electrons. So, for both hydrogen and helium, they are stable when they have 2 electrons, not 8, in their valence shell. In order for atoms to become more stable, they will gain, lose, or share valence electrons through the formation of different chemical bonds. There are 3 common types of chemical bonds that we will review: ionic, covalent, and hydrogen bonds. We'll focus on ionic bonds in this podcast. Ionic bonds form when an atom donates 1 or more of its valence electrons to another atom. The atoms that have lost and gained these electrons have now become positively and negatively charged ions. Ions with opposite positive and negative charges are attracted to each other, and the attractive force that holds them together is the ionic bond. An example of an ionic bond is the formation of NaCl, which is sodium chloride or table salt. A sodium atom has 11 protons and 11 electrons, and is electrically neutral with a net charge of 0. Its electrons are distributed in its electron shells, with 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in its third, or valence shell. Sodium has 2 options to achieve stability. It can gain 7 more electrons to fill its third shell with a total of 8 electrons, or it can lose that 1 electron hanging out in its third shell, which will then leave 8 electrons in its second shell, which now becomes its outermost valence shell. Atoms will take the path of least resistance. It is energetically more favorable for sodium to lose just 1 electron in order to achieve stability rather than gain 7 electrons. So after sodium loses its 1 electron, it now becomes a positively charged sodium ion, or cation, with a charge of +1. It still has its 11 protons, but it now has 10 electrons, so there is now 1 more positive charge than negative charge. An atom of chlorine has 17 protons and 17 electrons. Its electrons are distributed in its electron shells, with 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in its third or valence shell. Chlorine also has 2 ways to become stable. It can lose the 7 valence electrons in its third shell, leaving 8 electrons in its full second shell, which is now its valence shell. Or it can just gain 1 electron and add it to the 7 valence electrons in its third shell to make a total of 8 electrons. Again, atoms will take the energetically easiest route, so chlorine will gain 1 electron to its third valence shell rather than lose 7 electrons. And where will this electron that chlorine has to gain come from? Well, it just so happens that there are sodium ions in the neighborhood that are in the business of donating electrons. So after chlorine gains its 1 electron, it now becomes a negatively charged chlorine or chloride ion, or anion, with a charge of -1. It still has 17 protons, but it now has 18 electrons, so there is now 1 more negative charge than positive charge. The opposite positive and negative charges of the sodium and chloride ions pull them tightly together in the formation of an ionic bond and the resulting compound of sodium chloride, or NaCl. Most ionic compounds are tightly packed solids and form a crystal of ions, which is an ordered, repeating arrangement of ions found in fixed relationships with each other. In the body, most ionic bonds form between ions packed together in the bones and teeth, giving them great strength. But even though ionic bonds can provide strength and support, they are weaker bonds in comparison to covalent bonds. Many ionic compounds can break apart or dissociate into their positive and negative ions in an aqueous or water-based solution. These ionic compounds are called electrolytes. Electrolytes are dissolved in body fluids and create areas of positive and negative charge difference inside and outside of a cell, and because of this are able to conduct an electric current. We'll be further exploring this electrochemical gradient in Chapter 3. In addition to sodium ion, some of the other common cations in the body include hydrogen ion, potassium ion, ammonium ion, magnesium ion, calcium ion, and 2 types of iron ions. In addition to chloride ion, some of the other common anions in the body include fluoride ion, iodide ion, hydroxide ion, bicarbonate ion, oxide ion, sulfate ion, and phosphate ion. Thanks for watching, and please feel free to contact me by email at rjswatzk@hack.edu if you have any questions or comments about the course.